Okay then, Year 6. So what we are looking at today, our WALT, is we are learning to know equivalent fractions, decimals and percentages. So that's what we'll be looking at today. Now, we spent quite a few weeks before Christmas looking at fractions, a bit of time just before Christmas looking at decimals, and then just before we finished last week we had a lesson on percentages, and we looked at that yesterday, we reviewed that yesterday as well. So today is kind of consolidating everything that we've been doing so far, looking at equivalent fractions, decimals and percentages. And what's really important before we start is just remembering about this word here, equivalent. You can see the first part of this word sounds like equal. Equivalent just means the same, okay, exactly the same size. So we're going to be looking at equivalent fractions, decimals and percentages that are all equal to each other. So if we just have a quick recap of what we learned yesterday, that percentages is out of 100 and it is represented with that symbol there, the percentage symbol representing 100%. Now we're looking at equivalent fractions, decimals and percentages today, and fractions, decimals, percentages are three different ways of displaying the exact same information of a number or a product of something that is less than 1. 100% is if it would be the whole, that's the percentage, P for percentage there, D for decimal. The equivalent decimal would be 1.0 because it is a whole, and if we write F for fraction, an equivalent fraction would be anything where the denominator and the numerator are identical to each other. It could be absolutely anything. It could be 3 over 3. It could be 88 over 88. Absolutely any fraction where the numerator and the denominator are identical, that's a whole. That would be equivalent to 100% or equivalent to 1 in a decimal. Sometimes we can write this as 88 over 88, for example, or 1 whole, can't we? So they're all identical, they're all equivalent fractions, decimals and percentages. And what we'll be doing today, we'll be looking at how we can convert to a percentage or to a decimal or to a fraction, because if you can manipulate the number to turn a fraction into a decimal or a decimal into a percentage or a percentage into a fraction or vice versa, then it will make all your maths, not just the rest of this year but further on in high school and beyond, much easier if you can manipulate those numbers. Some people prefer turning things into fractions, some people prefer turning them into decimals, some people prefer percentages, but if you can manipulate the number depending on the context, it will make your maths understanding far deeper, and it will also really help you when you go off into high school. So looking first of all, so we'll review a little bit what we did yesterday. So if I had 18 over 100 as a fraction and I wanted to convert this into a percentage that was exactly the same size, that was equivalent. So remembering what we looked at yesterday, percent is out of 100 and this fraction has already been split up into 100 separate pieces. So remember what we said yesterday, that the numerator becomes the percentage. Those two are identical in size. Now the extra bit of learning today looking at is putting this into a decimal. Now we have looked at this just before Christmas, converting fractions to decimals, and the easiest way to do this is if we were to draw a very straightforward place value chart. The ones column, the tenths column, hundredths column and 1,000ths column. So if we were to put this fraction into this place value chart, we can see it's split into 100 pieces. So we need to ensure we have a number in here. So the 8 will be coming into here. The 1 there, we know it's less than 1, so it'd be 0.18. So all of these three numbers, 18 over 100, 18% and 0.18, they're all completely identical in size. It's really important before we go on that you understand that they're all identical in size. If I was to give this amount to Connor, 18 over 100. If I was to give this amount to Olivia, 18%. If I was to give this amount to Ruby, 0.18. They'd all have exactly the same. It is just 3 different ways of displaying the same information: fractions, decimals, and percentages. So we will have a go at one more. I'll just clear this board. So if we have a go at another one, I'll do it again with a fraction being over 100 before we do the next step. So if I was to have 77 over 100, so the denominator is 100 here, so that means that we don't need to change this, because remember, percent is out of 100. This has already been split up into 100 pieces. So the numerator becomes the percentage, and some of you already will be able to figure out what the decimal is, but let's prove it by putting it in here. Split into 100 pieces. This is the hundredths column, so we know that this second 7 has to come in here. The first 7, that would be in the tenth column, goes in there. We know it's less than 1, so it's 0.77. And these 3 numbers are all equivalent to each other. Hopefully you're all following me so far. So those 2 that we've done there, reasonably easy because the denominator was 100 in the fraction. It's quite rare that that will happen. So what do we do if the denominator is different? So if I had a fraction that was 10 over 50 there. So we know percent is out of 100. So we need to do something to this 50 to turn it into a percentage. So just like we did yesterday, it needs to be times by 2, doesn't it? It needs to be doubled. And so does this. Okay, it's still an equivalent fraction, it's still the same size, but we've just converted the denominator to 100. So 50 times by 2 is 100, 10 times by 2 is 20. So these 2 are equivalent to each other. The denominator is now 100, which percent is out of. So the numerator becomes the percentage. You've probably already spotted what this decimal will be, but we can write it in here. Split up into 100 parts. So this 0 would come in here, the 2 would go in there, and we know it's less than 1, 0.20. Now we've discussed quite a few times with a decimal number, if you have any zeros at the end with no other numbers afterwards, we don't need to write that down because we know that there's nothing in the hundredths column, just like there's nothing in the thousands, but we don't need to write a 0 there. So 0.2. 0.20 is okay, it's the same size, but if we're writing it in the correct way, it would be 0.2. So let's have a look at another one. So what would we do if I had 88% this time? I haven't started with a fraction this time, I've started with a percentage. If I've started with 88%, I'm looking at putting that into a fraction. I'm looking at putting it into a decimal. So let's put it into a fraction first of all. We know percent is out of 100, so our denominator is going to be 100. Then we're just doing the reverse. The percentage becomes the numerator, so we've got it as a fraction now. It can be simplified, but we'll look at that in a moment. Putting that into a decimal, it's been split into 100, 0.88. So lots of you are very adept at simplifying this. So we've talked, particularly in my class, about that method. We talked about the Connor method. We talked about halving until you can't half anymore. So we could do this. Can we continue on with this? Yes, we can. And then we look at that. Is there any number that goes into both 22 and 25? No, there isn't, so that is in its simplest form. So all of those fractions on that board, all of those percentages and decimals, they're all identical to each other. So let's have a look now if we start off with a decimal. If I've got 0.14, okay, 0.14, and if I was to write it in here, this has gone into the hundredths column, so we know as a percentage the denominator is going to be 100. We know that there is 14 parts to it, So that would come in here. And as a percentage, this is out of 100, percent is out of 100. So it will be 14%. And you can see that the fraction decimal percentages equivalent to each other, absolutely identical in size. So let's have a look at another fraction, and let's do it with a number that is slightly different, with a denominator of, let's go with 200. 200, and let's go with 8. So looking at this, we're trying to put it into a percentage. We know that percentage is measured out of 100. This is clearly bigger than 100. So what do we need to do for this? I'm going to go through this one, and then after that I'll give you some of your own to do. So it needs to be divided by 2. It needs to be halved. So 200 divided by 2 is 100. 8 divided by 2 is 4. So as a percentage, it would be 4%. Now, as a decimal, you've got to think carefully about this one. Now, it's been split up into 100, so it'll be coming into the hundredths column. And remember, we need the number in there. Now, the 0 does have to go in here because there are no tenths in there, and we know it's less than 1, so it'd be 0.04. If in this one, if you were to put the 4 in this column, it would turn the answer into 0.4, which would be far, far too big, because that would be 40%, or 40 over 100. It's 10 times bigger, so we need to ensure with this one, because it's been split up into 100, it goes into the hundredths column, so it would be 0.04. Right, so we are going to have a go now, and I'll stop the video in a moment, and you have a go at this one for me. So if I have 96%, so you can work out what that is as a fraction and as a decimal. So you might want to pause the video there whilst you have a go at that. Okay, so 96%, denominator of 100, the percentage becomes the numerator, 96 over 100. If we was to write that in there, it'd be 0.96, 0.96. And you can see there that is quite close to a whole. If you had a phone or an iPad or something similar and it was a 96% battery, you'd be pretty happy with that, because you know it's very close to 100, it's close to a whole. Whereas if it was lower, you'd be a bit concerned because you know it's a smaller number. But this one, you know, is very, very close to a whole, very, very close to 100. Okay, so they are 3 equivalent fractions, decimals, percentages. They're all exactly the same size, displaying the same information, but just in 3 different ways. So I'll give you another one for you to have a go at now at home. What if I had 14/20? So think about what you need to do to this 20 to turn it into a percentage. So you might just stop the video there whilst you have a go at it. Okay then, so we've got 14/20. Now percent is measured out of 100, and this number is clearly not 100. So what do we need to do to turn it into 100? We need to multiply it by a number. Several different ways you could do this. You could do 100 divided by 20 to work out what that is. You could look at, you could count up in 20s, 20, 40, 60, 80, 100, get to 5 there. So we know that we are timesing by 5. We need to do exactly the same to the numerator as well, because it turns it into an equivalent fraction, just like that. So 14 times by 5. Now we don't know our 14 times tables. We do know our 5 times tables. We know that 5 times 10 is 50, and then we could count up going on in 5 4 times, couldn't we, to take us to 70. And we can double check that is the correct answer by doing this. 5 times 4 is 20. 1 times 5 is 5, and 1 is 7. Just to double check. So 70 over 100. Now we've changed this now to 100, which percent is measured out of. So the 70 of the numerator becomes the percentage, and we could write this in here, 0.70. Remembering this 0 isn't necessarily needed. 0.7. So this decimal, this percentage, and these two fractions are all identical in size. But what you've done, you've just converted this fraction to the denominator of 100, which means that you can work it into a percentage, which means that you can see what it is as a decimal as well. Right, we'll have a go with another one for you to have a go at yourself. What about 0.8? Shall we go with that one? Might want to pause the video now. Okay, so you have 0.8. So if we were to write this in here, 0.8, and we to put that into a fraction now, it's into the tens column, isn't it? Which is 8 over 10. Remembering that we need to put it into a percentage, so it needs to be out of 100. 10 times 10, 8 times 10 turns it into 80 over 100, so as a percentage it will be 80%. This can also be simplified. If we were to half and half, turns it into 4/5. So these three fractions are all identical in size, as is this percentage, as is this decimal. Right, I'll give you one more to have a go at, and then we will end this part of the lesson and give you some questions of your own to have a go at. So I'll give you another fraction to convert, just because there's normally one extra step that you need to do when you have that fraction. So if I give you 20 over 2000, right, and you might want to stop that video there and have a go at it yourself. Right, so we've got 20 over 2000 here. So we need to turn this 2000 into a percentage. So we need to turn it into 100. So how are we going to do that? We need to divide by 20. That's how we do this, because how many 100s are there in 2000? Well, there are 10 in 1000, there's another 1010, so there are 20, so we need to divide them both by 20. So 2000 divided by 20 gets us to that magic 100 that we're looking for percentage. 20 divided by 20 is 1. So we're into 100 now, so the numerator becomes the percentage, so it's 1%. So very, very small. If you had 1% battery on your phone, you'd be scrambling around like crazy looking for your charger. So it's incredibly small. So 1%. Now, if we were to put this into a decimal, now it's been split into 100, so we need to put the 1 in the hundreds column. There are no tenths there, and we know it's less than 1, so it would be 0 in there. 0.01. Again, remembering where you are placing this 1. It's been split into 100, so it has to go into the hundreds column. If you were to put it in the tenths column and turn it to 0.1, that would be 10%, or it would be 10 over 100, which would be wrong. Again, it would be 10 times bigger, so just take care in that with that place value chart. Now, it might be useful for you to draw one of these out, these place value charts, when you're having a go at this yourself. There is some work that has been set for you, so have a go at that, send it back to your teacher. Good luck with it, and we'll have another maths lesson tomorrow. Thanks a lot, Year 6.